Hey everybody, this is Khashiyar. Welcome to part 3 of Tic-Tac-Toe with Python and Turtle. Now we are in a point that we need to take care of computer moves. So if you ever code Tic-Tac-Toe, you know we always need to have check-win. So in check-win, we are actually checking the positions of your list in indexes. So we say, okay, player 1, if player 1 have characters in index 0, 1, and 2, then it's mean. So it means like we are checking only one person or one side of the game. Now, in for computer moves, we need to do it for check wins, of course, but we need to check both sides one move before the check win. I tried to explain it, but anyway, before we can write some kind of conditional decision making, we need to have a structure for that. So I mean, kind of skeleton, or any kind of decision making, we need to have a skeleton. And here, let's take care of a couple of things in our class. Self dot corners equal a list of 0 to 6 and 8. Obviously, these are the corners of the board. And we need to have checklist self.win positions, which it's not actually checklist, it's positions we are going to use as a reference for checklist function. So we need to have a list, and inside the list we have to have 0, 1, 2, and I think you know the rest, and 3, 4, 5, and 6, 7, 8, so let's come down here, and 0, 3, 6, 1, 4, 7, 2, 5, 8, and 0, 4, 8. Oh, no, not that. 0, 4, 8, and after, and 2, 4, 6. Okay. Now, when we run the game, of course you know, but for whoever watching and don't know how the check wins works, let's say, for example, this is the board. This is 0, 1, and 2. And after, we are going to check if this row is all with one element or a character or whatever item, and it will be in the game, or from this side or diagonal. So we have 8 possible position, no more nor less. Okay, and in any game there just one of these positions going to happen. So we have 8 possible win positions, but only one position is going to happen in each game, no matter what. So now we create another attribute, which is our still list. So we call it semi positions. And actually this is very long list, so then I copy it from another what I already wrote and here, so we don't waste time that much. All right, now you might say, okay, we have 0, 1, 2 here, and we have 0, 1, 2 here, but in win positions we are checking this checklist against only one player, but here we are checking against both players. So here we are checking if the in index 0, index 1, index 2 is item X, for example, but here we are checking 0, 1, 2 if item X and item O. So we are checking against two elements here. So we are not going to have a win by have some if we write condition and the condition match, we are not going to win the game. I try to explain it a little bit more when we are getting there. And now let's go to our computer. And in player, let's say, okay, now the player made a move, then just call the computer function self.computer. Okay, and in computer we can write some indicator or something like print this is computer move. Okay, so when we run the game, this is computer move here. Now we know that our function call is working perfectly. So this moves here, we have win positions, which are 8 possibilities, and after we have semi positions, which they are 24 positions. I think 1, 2, 3, 4, 6, and 9, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there are 24 positions, and most of the time one of them occur and we have to prevent them or go toward them, and just maybe there is 1 or 2 possibilities that we have 2 win positions possibilities, and that's I don't know what they call it, maybe they call it fork or they call it L win, I don't know. And anyway, then we can come down here to computer move, and we have this print here. So what we need to do, for computer move, first we need to have some kind of opening. Then same as here, we have semi positions, then we have to go one step back and define one function opening self. Or can call it get opening. And also we need to have one counter here, self.count equals 0. With self.count we can check how many moves been made. So let's say user made a move here, then self.count plus equal 1. Okay, and now in self.opening we can use this counter to indicate where are we standing on the game, like it's a one move made, 2 move made, and depends on that we can decide. So if self.count equal 0 means this is the nothing happened, the board is empty. We need to have some kind of variable, we call it C spot for computer spot. C spot equal random dot choice self.corners. So if no move made, computer will go for one of the corners. Then return C spot. Now if self.count equal 1 means this is the second move, like user made a move and now it's computer turn, then there should be something on the board. But it really doesn't matter, it only matters if the first move captured the center of the board or one of the corners. So if self.count equal 1, then if self.board 4, which is the center of the board, is empty, then C spot equal 4 and return C spot. Now, if self.count equal 1, no, there is something I need to add here. If self.board, okay, first we check if self.board 4, like center of the board, is empty, we go for it. Now what if it's not empty? So it means the first player been already take that place. So self.board 4 is not empty, then again C spot equal random.choice self.corners and return C spot. Okay, something like that. Okay, if self.count, so we are just took care of one move here. Then let's come down here, and after this, let's say now self.move equal O. We change it because we need to add it to our list. And here C spot equal self.get opening. And let's say print, C spot. So if it's working, C spot. Okay, let's see. Something, where is it? Line 42. Line 42, yeah, if self.board, yeah, equal this. Okay, 4. Then we go to computer function, and computer decide 4 because one of the corners, we took one of the corners and he go for the center. Now let's check if we choose the center of the board, what he will do, or what she will do. I don't know if the computer is he or she, what it will be do. Whatever. Yeah, 6. So we have the center of the board, and it goes for randomly for one of the boards. So it really doesn't matter if we check the 0, 2, 8, or 6. The position will be same. Now we have the index. How we can mark that index on the board? You see here we have get the spot. Now we need to reverse this process, and from the coordinates go to the spots. Also in my original game, I didn't write something like get the index, something like that. I just add everything into computer function. So you can just create another function for it, or you can just go with me here. Then if C spot equal 0, then self.x equal minus 160 and self.y equal 160. And if, let's write all these if statements, I copy here. Or something like this. Yeah. 1, 2, 3, 4, 5, 6, 7. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 index, 9 positions. If it's 0, if it's 1, if it's 2, 3, 4, 5, 6, 7, and 8. Okay, and let's copy this also. Yeah, it's a little bit of hard coding here. Also y coordinate. No. And now if it's 1, then x coordinate will be minus 80, minus 80, y coordinate will be 160, and after, if it's 2, self x coordinate 0, y coordinate 160, and if it's 3, it will be minus 160, and y coordinate will be 80. If it's 4, minus 80, minus 80. If it's 5, 0, 80. 0, 80. If it's 6, minus 160, 0, 60, 0. And if it's 7, minus 80, 0. And if it's 8, 0, 0. Okay, now also we have the spots. Let me check one more time. Minus 60. And after this, looks okay. Then it's okay until it's okay. If we find any problem, we can come back. Now, we are still in computer opening. We are still in, actually this line should be in computer. I thought I'm in computer function. We have to change it. We have to copy everything here. Okay, cut it and come down to computer, and we paste it here. Okay, now that we have our coordinates, let's print them so we can be sure if we have the coordinates. So here we can print self.x, self.y. Yeah, so let's see what we've been doing. Oh, why it's go so slow. Okay, now we made a move, and after from user we call the computer function, and in computer function we change the move to O, change the character, and we create a variable, and we get the opening, and here we come up again, opening, we check how many move made, and depending on that we choose if we have the computer go for center of the board or for the corners, and in any way return the C spot. And in C spot here in computer move we get the C spot and we print the C spot just to be sure, and here in these lines we just convert the index to coordinates. Now that we have the coordinates, let's change the shape. Self dot shape is circle. Self dot shape size 2.5, which I find it's best, and self dot pen color will be still white, or you can choose whatever you like. Self dot fill color will be black, because we actually use one of the turtle's default shapes, which is circle, and if we just use pen color it will stamp as a bold circle, fill it up with water, with white color, not water, fill it up with white color on the board. And now we can say self dot go to self dot x plus 10. I find it's best spot for starting drawing the shape, and self dot y minus 10. And after we have to add the element to our list, self dot board C spot equal self dot move self dot count plus equal 1, and finally self dot stamp. So let's see if it works. Where is it? Wow, in the wrong place, in a very wrong place. Then I think we have something wrong with these coordinates. Okay, let me check. The 8 should be 0, 0. The 7 should be minus 80, 0, which is correct. The 6 should be minus 160, 0, which is correct. The 5 should be 0, 80, which is correct. The 4 should be minus 80, 80, not minus 80. We have 280, minus 80. Then 3 should be minus 160, 80, which is correct. 2, 0, 160 is correct. 1, minus 80, 160 correct, and 0, minus 160 minus 160 is correct. Okay, let's save it, and one more time. Okay, now all right, now we have the right spot, and also we have the right stamp. Now, one more time, we choose this time the center of the board. So by that, computer have to choose one of the corners. Nice. And this corner will be kind of randomly. not kinda randomly, it will be randomly. Yeah. Okay, now we have progress. The next step, we need to take care of a little bit more complicated code. Not that kind of deep complicated, but it's a lot of if statements, and we need to take care of check win and semi position wins. So I leave it for next video. Thanks for watching, and please subscribe if you like my videos. See you in next video.